Welcome and bienvenue to this lecture on half-angle formulas. Once again, be familiar with half-angle formulas, but instead of memorizing them, know where to find them and how to use them. Again, in your book is probably a proof of the half-angle formulas. I'm going to save you that, and we'll just go ahead with some examples where we're using them. So the first example that we're doing is for cosine A equals 3/5 with A in quadrant 4, find sine of half the angle, cosine half the angle, and tangent half the angle. I just wrote down here equation editor, so we'll be using that. First, we're going to look at sine A over 2. So I'm going to do that. Sine of A over 2. And then we just look at it, equals square root of fraction 1 minus cosine A divided by 2, capital A, I guess. And because the square root is taken, we come out with plus minus there. And then we'll choose whichever we need because we're in quadrant 4. So let's plug in numbers. See. So sine A over 2 comes out to 1 minus cosine A. Well, there it is. Just plug in the 3/5. And then we're in quadrant 4, so our sign needs to be negative. So I'll put that negative in the front there. And then I have equals. Let's see what we come up with. That's going to be 2/5 divided by 2, which is 1/5, so this negative the square root of 1/5. So negative the square root of 1/5. Okay, let's see what we get for the next one. And actually, I believe I can almost get this on one line here. Let's see if this works. Yeah, I believe so. That way, save a little bit of space. Okay. Cosine A over 2. So for cosine A over 2, we have plus minus 1 plus cosine over 2. So 1 will plus given 3/5. Then we're in quadrant 4, so actually that one here is a plus, and so we're going to have 8/5 over 2, so we're going to have square root of 4/5, and if we really wanted to, we could write 2 over the square root of 5, but I'm just going to leave it like this. And the third one is going to be tangent over 2. I'm going to scroll a little bit down. So tangent A over 2 plus minus 1 minus cosine A divided by 1 plus cosine A. You can easily derive that from the other two. As you divide sine over by cosine, you come up with this particular fraction. So we have 1 minus 3/5 divided by 1 plus 3/5. Let's see, so we're going to come up with, let's see, 2/5. Yeah, 2/5 divided by 8/5, which is going to be 2 over 8, or 1/4. Take the square root of that, and we come up with 1/2 simply. And despite that, I already know that I made a mistake on the last two. For now, we're in quadrant 4 with the tangent, so the negative needs to be there. However, here's the little trick. A was in quadrant 4, but where's A over 2? Well, A is going to be between 270 degrees and 360 degrees, so A over 2 needs to be in between 135 and 180 degrees, which means a over 2 is in quadrant 2. And accordingly, I actually need to adjust each one of these here. So sine in quadrant 2 is actually positive. So sorry about that gaffe. Cosine in quadrant 2 is actually negative. And tangent in quadrant 2 stays negative, just the way I accidentally had it. And with that, we're done with this example. And one more example where we determine tangent of 15 degrees. What's tangent of 15 degrees? Well, I use the equation editor again. This here is the identity. We're going to get rid of this here in the back. And we have tangent of 15 degrees equals tangent a over 2. That means that that a is 30 degrees. 30 over 2 is 15. So actually here what we have is 30 degrees. So that's what I'll be plugging in right there. 30. Whoops. Okay, whoops. Cosine 30 degrees. Then we are in quadrant 1, so the tangent needs to be positive. And then what we have is, now it gets interesting. We have 1 minus the square root of 3 over 2. And then we have here square root of 1 plus the square root of 3 over 2. So we have a square root within a square root, and this is the way it looks like. Just about as complicated as it can get. So square root of 3 over 2. And here. And with that, we should be done, but this last square root over a square root is just a little bit bothersome. It's actually correct. It's just a little bit rough. Well, what happens is that for the half-angle formulas for the tangent, there are actually several identities. So instead of using the normal one, I should have used one of the other ones. For example, this one or this one. So let's try that one instead. One of those. So again, this might serve as something that we have different options. So again, we come up with tangent a over 2, and now we may use, I have to scroll up a little bit, sine a over 1 plus cosine a. Sine a over 1 plus cosine a. Since I already know that I come up with square root of 3 over 2, it might just actually be easier to put that square root in the numerator. So I'm going to write here instead 1 minus cosine a, yet the third identity for the tangent a over 2 over sine a. And now we plug in numbers. So it's going to be 1 minus cosine of 30 degrees divided by sine over 30 degrees, and that will indeed look nicer. Okay, plug in the numbers. 1 minus square root of 3 over 2, divide by 1/2. or, as we take the reciprocal of that, 2 minus the square root of 3. And I believe that does indeed look nicer than the last one. And the last one is actually correct. It's just it would be very tricky to get rid of all these square roots. So this one looks better in parentheses. Use the third identity for tangent a over 2. And with that one, I conclude the lecture on the section on half-angle formulas.